Welcome back. Last video here is going to look at orthogonal curves, and so the language orthogonal, you may have heard this previously when you were studying geometry, but orthogonal is a synonym for parallel or perpendicular rather. Perpendicular is more of a two-dimensional specific case where we meet at a 90-degree angle. The idea extends in higher dimensions. It's just that more generally perpendicular is difficult to see in higher dimensions other than two. So that's why we use the language of orthogonal, because it's more of a general catch-all term. Okay, but here, two curves, as you might imagine, if you say two things are perpendicular, right, they have to meet at a 90-degree angle, right? And so if the way we're approaching it here in calculus is we say two curves are orthogonal if their tangent lines are perpendicular at each point of intersection. Okay, so what do we have to do? We have to, there's tangent lines built in here, so we need to find tangent lines. Okay, and then perpendicular, right? How do we show perpendicular, right? That's the idea that M1 is the opposite reciprocal of the other slope. So we need to find their tangent lines, look at their slopes, make sure they're perpendicular at the points of intersection. There's just no work for us to do, right? Just kidding. Let's get started. So we have these two curves, right? We want to show that they're orthogonal at this point. We might need to specify K and C as specific values to make sure that this is true. But so if we have this, right, and I'm going to call this y1 and this y2, okay, just so I know that they're different curves, right? So if I differentiate y1, what would this be? 2cx, right? Okay, that's a little too easy. Let's go to the next one. Let's differentiate this one implicitly because I have x squared and y squared. So this is more of an ellipse, at least as it's being presented right now. So differentiating implicitly, I get 2x plus 4y2 times y prime is equal to 0. Okay, so then if I solve for y prime, right, because I'm looking at tangent lines, so I need y prime here. Let's see, I'd subtract 2x, divide by 4y2, and reduce. I would just end up with negative x over 2y2. Okay, or over 2y. All right, so then, let's see, so then what do I know? I know that if these things are orthogonal, right, this is true. Another way to say this same thing is if I look at m1 times m2, that's equal to negative 1. And the tangent lines, or the derivatives would be the slopes of the tangent lines, right? So I want I should do y2 prime. Okay, so I'm going to look at y1 prime times y2 prime and say that that must equal negative 1 for this to be true. Okay, let's go through the arithmetic. What do we get? So we have 2cx times negative x over 2y is equal to 1. Okay, and then I'm going to say at 1, 1, what do I get? Well, I get, let's see, the 2's will reduce. Okay, let's just do it. 2c, negative 2c, and then x squared, so that would be 1 squared. Over 2 times 1 equals, oops, that should be negative 1. Okay, so then mathematically, right, like the 2's would reduce, so I'd have negative c equals negative 1, so then c should be equal to 1. Oh, that wasn't too hard. Okay, so there we go. And then what about k? Do I have to worry about k at all? In fact, I do. I just need to make sure that, you know, this ellipse passes through the point. So down here, I'm just going to make sure, okay, if I have 1 squared plus 2 times 1 squared, that must equal k, right? So it has to pass through the point. So then just k has to be 3. Okay, so then I'm going to say just a concluding statement to wrap everything up. The curves, whoa, that was really curvy. The curves are orthogonal at 1, 1 if c is equal to 1 and k is equal to 3. Okay, and that'll be enough for us to go on. But again, the overall idea of orthogonal, find the tangent slopes via the derivative of each of the functions, and then you need to make sure that if they are orthogonal, right, their product is equal to the product of their derivatives is equal to -1. Okay, so there we go. We are ready to tackle every implicit function known to man, or at least a few that we're going to see in class. See you soon.